Hey guys, just wanted to give you a quick tutorial on how to use these digital algebra tiles that I created to model polynomial multiplication problems. So for instance, suppose that we wanted to multiply the quantity of x plus 2 times the quantity of x plus 5. Now how might we do that? So note what we have here in blue. Note are all positive quantities. In red are all negative quantities. Each of these kind of line segments represents, in this case, a length of 1. Here, these line segments represent a length of x. These squares represent a square of area positive 1. This square represents an area of x squared. This rectangle, its dimensions are x by 1, or 1 by x. So their area is going to be 1 times x, also known as x. This is another congruent, identical rectangle to this one. It's just oriented vertically as opposed to horizontally. Kind of intuitively, negative areas don't really make sense, but we can use negative tiles to kind of help model situations in which I might have, I don't know, x minus 2 times x plus 5. In this example, we're just going to deal with positive quantities just to let you know kind of how to use these. So if I wanted to model x plus 2 times x plus 5, I might consider a rectangle whose dimensions were x plus 2 by x plus 5, and I think if we multiplied the length and width of that rectangle, we'd get an area equivalent to whatever this product is. So let's create such a rectangle. We're going to have its width be x, so that distance right there is x, plus 2, so plus 1, plus 2. I'm going to, excuse me, I'd like one of these horizontal line segments. I'm going to even drag over this one. Each of these items up here has like a cloner on it, so you can just drag and another one will be there to drag later. So I'd consider this length right here to be x plus 2. And we want this rectangle to have its other dimension be x plus 5. So here's an x, now just vertical. That's why there's kind of a vertical and horizontal line segment or these rectangles so that you can build whatever rectangle you want. So plus 5, so we're going to do 1, 2, 3, 4, 5. All right, so what I think we have right here is the outline of a rectangle whose dimensions are x plus 2 by x plus 5. And if we were to find the area of this rectangle, I think we'd be finding the product of what x plus 2 times x plus 5 is. So what is the area of this rectangle? Well, for instance, I think the area of this little portion right here, I think this is a square whose dimensions are x by x. The area of that portion is just going to be x squared. You see how this kind of fits nice and snugly in there. This portion right here is a little rectangle whose dimensions are 1 by x, so that's going to have an area of x, and we're going to have an identical area of x right there. Okay, let's keep on building. This rectangle and this rectangle, actually we're going to have 5 identical rectangles, each of whom also have dimensions 1 by x, and whose areas will be x. Okay, looking good. And what do you think we have remaining are a lot of squares whose dimensions are going to be 1 by 1, 1 by 1, 1 by 1, 1 by 1, etc., etc. So the area of this little sector is 1, the area of this little sector is 1, the area of this little sector is 1, and we're going to keep on doing this until we filled the rest of this rectangle. All right, so I think we have found the area of this rectangle, and I think the area is, well, we have an x squared, so equals x squared. I think we also have 1, 2, 3, 4, 5, 6, 7 x's, so plus 7 times x. And then I think we also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. So I think the area of this rectangle is x squared plus 7 times x plus 10, which also represents the product of x plus 2 times x plus 5. And this is the way to use these digital algebra tiles to model some polynomial multiplication. So we did one example here, and I hope that you're feeling comfortable doing some more on your own. So hope you found it helpful, and I hope you enjoyed.